Good morning, student. Here we have earlier started chapter number 3, geometry, and it is part number 2. In first part, we have studied how can we describe or how can we say that the given point or given thing is away from any other observation point. We have also taken one example that if we want to denote the position of lamp on the table, then we take two side, one edge and one bottom. So there were two side or two observation that we can denote the position of the given lamp on the table. Now we want to now denote the position on the position of a point on a plain paper or any plane. So how can we denote the position of any point by the Cartesian system? So the topic that we are going to learn here, that is Cartesian system, and then the exercise number 3.2 we will solve it. So first we understand what is a Cartesian system. As we know that the Cartesian system, it is a gift of the Rene Descartes, who have invented the procedure to denote any point on a plane. So first let we understand what is a Cartesian system. To understand that, let we recall some memories from the chapter number 1. You have already studied in chapter 1 number 1 the number system. We know that there is one line, and we know that it is a real line, real number line. We know that in real number line there is given one point between this line. It is known as origin of the line, and we know that the line is spreaded in both sides, left side and the right side from the origin. Here we know that the distance between 2 points is fixed. Here we denote the distance between 2 points is fixed. Here you know that the distance between 2 points is 1 unit. As here you can see that it is started from 0. If you run on the line on the right side, then you get positive numbers 1, 2, 3, 4, 5 and infinitely. And if you run on the left side of the line, then you can find -1, -2, -3, -4 and -5, as we have studied. Means the line contains positive and negative numbers and its origin is 0. If you start from 0 to right side, then all numbers are positive, and we start from 0 to its left side, then we find the negative numbers. And as you know that the distance between two numbers is fixed. If we take any consequence two numbers, then the distance between these two numbers always same, as we know that. So if we take the distance between any two number, any consequent number, then we get here as well given in the figure. You can see that the distance between 2 and 3 is 1 unit distance, and between -3 and -4 also 1 unit distance, and it is a origin. So by this way we can represent the number line as we have studied. Now we want to know the Cartesian system, the gift of Rene Descartes. So he take a combination of two lines and put it both the line in a perpendicular system. Here you can see that the Rene Descartes take two lines and put it in a perpendicular form. As you can see that The perpendicular means each other line intersect at 90 angle of 90 degree. Here you can see that it is a 90-degree angle. So both the line are perpendicular to each other. It takes some form of the line as given here. He also taken two lines as here, and after then he put the line in such a way, one horizontal line, as you can see here, one horizontal line and one vertical line, and it's a here middle of the both line. It is a intersecting point of both line, and it is the origin of both the line, as you can see here. So let we denote number on this both line, the horizontal line and also the perpendicular line. We put the points on both the line. So about that, about the horizontal line, let we denote the given line. We x dash x, the given line is x dash x. If we start, if we look at to the right side of this line, then we can find the positive area, means positive numbers. And if we look at the left side of this line, then we can find the negative numbers. So as well as it is a horizontal line, so we can also take the vertical line, as you can see here. Let we denote it by y dash y. We denote it y dash y, as well as we denote or represent the line x dash x. We can also denote the line y dash y. Here it is the origin of this line, and if we move on upside, then we can find here 1 2 3 4 5 and infinite. It is a positive numbers on the 0 to o, on the 0 to o. And if we move down, then we can find minus numbers. So it is a number line, two number lines, as you can here see that one is horizontal and one is vertical. So these lines are actually obtained as follows. Take two number lines, calling them x dash x and y dash y. Plane x dash x horizontal, as you can see here, and write the number line on it just as written on the number line. We do the same thing with y dash y, except that y dash y is vertical, we also, and not horizontal as we taken here. Now we take the combination of both the line. What we do? Now we take the combination of both the line, and we find the intersection of both the line is origin of both the lines. So we get such type of combination of both the line, as you can see here. So on the plane, this given is one plane, and we draw the axis, both the line intersecting at one point, as here you can see it is, we know that it is the origin of both the line, and the intersection of both the line is the origin. If we from the origin, if we move right side, then we can find positive x-axis, positive area, and if we move from the origin on the left side, then we can find negative numbers. If we move upside from the origin, then we can find positive number, and we move on the down from the origin, then we can find such type of negative numbers. So here the horizontal line, as you know that it is x dash x line, so we denote the horizontal line as a x-axis. What is said it? The horizontal line is a x-axis, and the vertical line is known as a y-axis. So from the origin, the right side of x-axis is a positive x-axis, and as well as the left side it is a negative x-axis. And for the y-axis, if we move on upside, then we can find the positive axis, y-axis, and if we move down, then we can find negative y-axis. So combine both lines in each a way that the two lines cross each other at their zeros, means its origin. The horizontal line x dash x is called x-axis and the vertical line y dash y is called the y-axis. The point where x dash x and y dash y cross is called origin, means here O is the origin of both the x-axis, x and y-axis, and it is denoted by O. Since the positive numbers on line on the direction OX and OX and OY are called the positive direction. Here you can see that OX and OY are having the positive number, so this direction, two direction are known as positive direction of the x-axis and the y-axis respectively. Similarly, OX dash and OY dash are called negative direction of the x-axis and y-axis. As you can see here, it is a negative direction of x-axis and it is a negative direction of y-axis. Now, so it is known as a Cartesian system to denote any point. Now let me understand how can we denote the point on this Cartesian. So here, if we take the combination of two lines, then you can see here it divides the plane in the four quadrant. Here you can see that if we take the combination of both the line, then it divides it in a four quadrant. If we move OX from anti-clockwise in the anti-clockwise direction, means here to this way. If you move it in a anti-clockwise direction, then you can find the first, the positive x and positive y, it is denoted by quadrant 1. The first positive x and positive y, it is denoted by quadrant 1. And if you move on, then you can here see that the positive y and the negative x denoted by the quadrant 2. And here positive x, negative x and negative y, it denoted by quadrant 3. And positive x and negative y, it is denoted by quadrant 4. So the number line, both the number line divides the plane, the whole plane into four quadrant, that is first quadrant, second quadrant, third quadrant and fourth quadrant in an anti-clockwise way. So you observe that the axis, plural of word axis, divide the plane into four parts. These four parts are called the quadrant, means 1/4 part of the plane. Numbered 1, 2, 3 and 4 anti-clockwise from OX. So the plane consists of axis and this quadrant. We call the plane, the given plane. If we draw two lines such as given here, then the plane, the Cartesian plane, we call it the Cartesian plane or the coordinate plane or XY plane. The axes are called the coordinate axis. So here, if we draw two lines as given here, intersecting at one point and both are in perpendicular, then the plane, this plane is called the Cartesian plane or coordinate plane or XY plane. So, and the axis of both the line are known as coordinate axis. So it is a Cartesian plane. Now, since every point on the x-axis has no distance from the x-axis, now we want to divide the point on x-axis and y-axis. As we know that since every point on x-axis has no distance from the x-axis, therefore the y-coordinates of the point lying on the x-axis is always 0. Means here you can see that two line as given here. It is y, y dash, x, x dash, here given 1, 2, 3, as well as here given 1, 2, 3, as also here. So the point on x axis means the point will be denoted on here, x axis. So here you can see that the distance on x axis from the x axis of the point on the x axis is 0, and you can see that the distance between the point and y axis, the distance between this point and from the y axis means we can find distance from y axis here as well as here. The distance between x the point and the y axis, as you can see here, it is a 0. So if we take the pair of coordinate as we take x comma y, the coordinates of the given point, we take the pair x comma y. It is a the coordinate of given point. Here if we take the given point is P, then the coordinate of point P is given by x comma y. X denotes the coordinate of x axis and y denotes the coordinate of y axis. Here you can see that it is a first number on x axis, so x is equal to 1, but the distance from the y axis to this point is 0. Means if they are given the point on x axis, then its coordinate is x comma 0, because the distance from the y axis is 0, where x is the distance of the point from y axis. Similarly, the coordinates of any point on the y axis of the form 0 comma y, where y is the distance from the x axis. So here always we take, if the point is given on the x axis, then its coordinates is always x comma 0. X is a distance from y axis, here y axis, then distance from here the distance from x axis, y axis is 1, but the y coordinates is always be 0 if the point given on the x axis. As well as about the point on the y axis, here if the given second one point q, then the distance from y axis denoted by y, so 0 comma y. So the on the y axis, if they are given one point, then the coordinates of this point 0 comma y, and y is the distance from y axis, means here to this distance is y axis. So if they are given the point on y axis, then its coordinate is 0 comma y, and if the given point on the x axis, then its coordinate is x comma 0, where the x is a distance from y axis and where is the y is a distance from x axis. What are the coordinates of origin O? Here we know that both axes intersect at one point, it is origin of both the line. So what is about the origin O? It has 0 distance from both the axes. As you know that the origin has a 0 distance from the both axes, so that its abscissa means coordinate of x axis. Here said abscissa is a coordinate of x axis, and ordinates means it's a y coordinate. So that its abscissa and ordinate are both 0. Therefore the coordinates of the origin are 0 comma 0. 0 is abscissa and here 0 is the ordinate. That is, abscissa means the coordinate of y axis and ordinates means coordinate of y-axis. Here x-axis and it is y-axis. So now about the point, what is a property of point on the in the quadrant? It was about we have studied in previous slide, that is it is a distance from x-axis if the given point is on x-axis or y-axis. But now about the quadrant, if the given point is in the quadrant, then what is the property and how it behaves? So we take, if the here given 4 point that we remember in the example above, you may have observed that the following relationship between the sign of the coordinates of the point and the quadrant of the points in which it lies. If the point is in the first quadrant, if the point is in the first quadrant, then the point will be in the form x is positive and y is also positive. Means if they are given the coordinate pair, the pair of coordinate x comma y are both, and the value of x and y are both positive, then it always lies in the first quadrant. Since its first quadrant is enclosed by the positive x axis and positive y axis, means the coordinate of the point P in the first quadrant is always positive x and positive y. About if the point is in the second quadrant, if the point is in the second quadrant, then the point will be in the form minus plus, because we know that in second quadrant there is given negative x axis and positive y axis. So the coordinate of x axis will be is negative, and the coordinate of y axis will be positive. Since the second quadrant is enclosed the negative x axis and positive y axis, as well as in quadrant 3 the point will be the form negative x and negative y. Means if the given pair of point P, the quadrant x is negative and quadrant y is in the third quadrant, y, the coordinate of y axis and x axis are both both negative, then it is in third quadrant. As well as if the given point is in fourth quadrant, then its x coordinate will be positive and its y coordinate will be negative, as we can see in the figure. So if the given point is in first quadrant, second quadrant, third quadrant or fourth quadrant, then we can find such type of graph as you can see here. In first quadrant, the coordinates of point both x and y always be positive. In second quadrant, if there is given any point in this quadrant, then the x coordinate will be negative and the y coordinate will be positive. Means because here given x axis is negative and y axis is positive, so x here the distance from x axis is negative will be, and the distance on y axis will be positive. So the point on this plane, this quadrant, and its coordinate will be minus comma plus. About here, if the given point is in third quadrant, then the coordinate of the point will be minus comma minus, because here given x axis is negative and y axis also negative, so its both coordinates are minus comma minus. And if the point given in the fourth quadrant, then you can see here here given x axis is positive and y axis is negative, so x axis is positive, so its x coordinate is positive and y coordinate is negative. So by this way this all system, the number system, to denote the number, to denote the point on the plane by the using this coordinate. So it is known as the Cartesian system. So now let me denote the point on this Cartesian plane or Cartesian system. So let me take example number 1. See in figure 3.11 and complete the following statement. Here F.Sec.Sec first given that F.Sec.Sec and the coordinates of the point B. Let me see the graph, and also we find the coordinates of point B. Here you can see that F.Sec.Sec means coordinate of x-axis, and ordinates means axis of coordinate of y-axis. So we here take, and after we put in the pair at the coordinate pair, as well as we solve all these number. We see the distance of x-axis and y-axis, and we fill up all this blank as given in example number 1. So here given the plane and x-axis, y-axis, and also given the given point. So here you can see that about point B, F.Sec means the perpendicular line crosses on x-axis. Here you can see that the coordinate of x-axis of point B is 4, and the coordinate of y-axis of point B is 3. As well as all these points you can see here, since the distance of point B from the y-axis is 4 unit. Here you can see it is y-axis. The distance from y-axis is 4 on x-axis. So F.Sec means the x coordinate will be 4, and the distance on x-axis from the y-axis, the distance on y-axis from the x-axis is 3 of point B. So its y coordinate is 3. Therefore the coordinates, y coordinate, that is the coordinate of B is 3, hence the coordinate of point B are 4, 3. As well as about the point M, here you can see that the distance from y-axis on x line is -3. So its x coordinate is -3, and the distance from x-axis on y-axis is 4 for the point M, then the y coordinate is 4, as well as -3, 4, as the x coordinate is -3 and y coordinate is 4. About point L, the distance of the distance from y-axis on x-axis is -5. So its x coordinate is x coordinate is -5, as well as the distance from x-axis on y-axis of L is -4. So and it is in fourth quadrant, then we can see here -5, -4, as well as we can find for the x coordinate on y-axis is 3, and y coordinate on y-axis is -4. So by this way we can denote the coordinate of any point on the plane, as well as write the coordinates of the points marked on x-axis. So here we take here given one graph, as well as you can see here. Now we want to denote the coordinates of both the all the numbers. About A, here you can see that A is lying on x-axis. So the distance from y-axis on x-axis is 4. So means its x coordinate is 4. but the distance from y axis on from x axis on y axis is 0 because it lies on x axis, so its coordinate will be x comma 0, and here the value of x coordinate is 4. So the coordinate of A are given as the point A is at a distance of plus 4 units from the y axis and it's a distance 0 from the x axis. Therefore the x coordinate of A is 4 and the y coordinate is 0. So hence the coordinate of A are given are 4 comma 0, as you can see here. As well as about B, the distance from x axis on y is 3, means its y coordinate is 3, but the distance from y axis on x axis is 0 for the point B. So the coordinate of point B are 0 comma 3. As well as about C, minus 5 comma 0 y, as you know that about C it is lies only on x axis, but there is not given distance from x axis on y axis, so its coordinates are minus 5 comma 0. About D is also 0 comma minus 4 because it lies on y axis, so we only denote the coordinate of y axis and put the coordinate of x axis is 0. And about E, the coordinate of E are 2 by 3 comma 0. So by this way we can denote the coordinate of any points on a plane, and it is known a Cartesian system to denote the position of point on any given plane. So solve some example given in the exercise number 3.2. Solve examples 1 and 2 given as in the exercise number 3.2, and all are so simple that you can solve it easily.